Hello and welcome. Today I want to talk about MMICs. It's happening quite often that you just look around on some websites of semiconductor manufacturers and you see a part that's really standing out and you really like, got good performance, it's fairly reasonable in price, you would really love to use it for a project, but then you run into a situation where you say, okay, well, I really don't know how to go by using this part, because of course the MMIC is one key component, but there's quite a bit of additional work required to make an MMIC into an actual amplifier that works reliably. So first of all, you of course need a circuit board, and then the mechanical design of proper housing, bias circuits, all this kind of things. And so it's quite a bit of work, and there are some challenges to it. The first one, of course, is the circuit board design. You need appropriate software to do that, and then of course in the case of this specific part right here is a TGA 2623CP, which is a fairly nice part for 10 gigahertz and other expand applications. And this is in a pull-down package, but in order to use this part you need a circuit board that's made out of Rogers 4003C material, and it's 0.2 millimeter high, simply because if you look at the pin spacing and the pin width, you can't really use anything that's higher in circuit board height, because the lines are just getting too wide, and that creates problems, especially with the 50 ohm pin in the center of the integrated circuit. So if you look at the outline of this part, you see that the 50 ohm pin to the left and to the right in the center of the part, it's only about 0.010 inch, so it's about 0.25 millimeters, and the spacing in between the ground pin and the center pin, it's 0.046 inches. So you can't really use a board that's 0.5 millimeter or 0.79 millimeters, what's commonly used and accessible. So it needs to be 0.2 millimeters, because the 0.2 millimeters translates into 0.4 millimeters for 50 ohm line, and that interfaces nicely with this center pin. So then of course you need to find a board manufacturer that can process 4003 in 0.2 millimeter height, which is a little bit of a challenge because not all board manufacturers are offering it and processing it, and the majority covers board heights with 0.5 millimeters or higher. And then once you find a company, and there are some offshore companies who do it fairly reasonable, but you usually end up with paying a lot charge of $350-400 to get it done. And so of course once you get the board done, then you also need mechanical design, so you basically need a housing and all that. So you need a drafting software like SolidWorks or something, and familiarize yourself with it, and make an appropriate drawing for housing, find a machine shop to get it done. So it's quite a bit of work to do all that, and there are a lot of challenges to overcome, and of course it's also a costly endeavor, especially if you've never done it before and you don't know which shops to use. So it can be quite challenging. So so to make things easier for amateur radio operators or even commercial users, we created shell kits, which basically make it very easy to use an integrated circuit. And so here are the components that are usually part of a kit. We have the appropriate machined housings, so they're all drilled and tapped and have a gold iodine surface coating on it to give it a professional look. Then we got the circuit boards, and I got a circuit board here for qorvo CP package parts and Wolfspeed CMPA parts. And then we got a bias board over here. So it's a regular bias board for continuous operation. And then for amateur radio use, we also have a bias board right here that incorporates PTD control. And for this particular board right here, we have a bias cavity, and this cavity mounts on top of the housing right here, and then basically the bias board goes inside. And of course there's a lid that goes on top of all of that. On the side of the housings, we get drilled in tap tools for feed-through capacitors or filters and SMA connectors. And so basically when you order a kit, this board right here comes completely populated with the appropriate bypass capacitors and resistors mounted inside the cavity of the housing, and with the coax connectors attached, and then of course also the bias board is populated. And so all you gotta do is really insert the device, bolt it down, and hook up your bias board, adjust your IDQ, and then you're pretty much ready to go after adding a heatsink. What is also provided is for bolt-down packages. Usually you can use thermal grease like Arctic silver, something similar, but we usually provide a piece of indium foil, because indium foil provides a better thermal interface than Arctic silver or other thermal compounds, so that's also part of the kit. And like I said, those kits are fairly nice and easy to use solution, and we offer them for a wide variety of MMICs. I just shown you over here two of the potential solutions we offer, but we also offer them for other MMICs, mostly qorvo made parts, and we can also create solutions custom based for whatever MMIC you want. And of course we also offer turnkey solutions where we completely offer assembled and tested amplifiers. So that's it. Thank you very much. Thank you for your attention, and don't hesitate to contact me at lothar@texasmicrowave.com. Thank you.